Bonsoir tout le monde. Bienvenue à Raw Material Company. Je m'appelle Senegal, je suis commissaire des programmes ici. Tout d'abord, avant de commencer, on voulait vous informer qu'il y a des casques qui sont disponibles pour la traduction en anglais et en français. Donc, vous pouvez vous rapprocher ici à l'équipe technique, ou bien on va faire circuler un plateau avec les écouteurs et vous pouvez le garder au cas où par rapport aux échanges si vous avez besoin de la traduction. So, there are earpieces for translation that we have available. We suggest that you have it on hand in terms of the conversation. There's English on channel 1 and French on channel 2. Donc il y a un marque qui circule avec les répétiteurs. Alors, Raw Material Company est un centre pour l'art, le savoir et la société basé à Dakar. C'est une initiative qui s'articule autour du commissariat d'exposition, de l'éducation artistique, de résidence, de la production de savoir et de la documentation de la théorie artistique et de la critique d'art. Raw Académie est un programme résidentiel expérientiel pour la recherche et l'étude de la pratique et de la pensée artistique et curatoriale. Raw Académie expose les participantes et les intervenants et intervenantes à l'environnement artistique dynamique et historiquement critique d'une ville, tout en leur offrant un espace libre pour exploration, l'enquête, la recherche, la production de leurs propres idées. Le programme est conçu pour promouvoir un échange et un dialogue intense organisé autour de sessions publiques et fermées qui comprennent des séminaires, des conférences, des ateliers, des expositions, des visites d'institutions culturelles et des publications. Le programme se déroule généralement à Dakar pendant 5 à 7 semaines, mais peut être déployé en fonction de son thème dans d'autres zones géographiques. Chacune de ces sessions s'articule autour d'un cadre conceptuel pertinent pensé par un directeur ou une directrice dont la pratique démontre une approche originale de l'art, du commissariat d'exposition et de la critique d'art avec l'apport confrères qualifiés invités.
Bonjour, je m'appelle Hajifanta, je suis assistant commissaire à Raw Material Company. Sense of place, displacement, replacement, non-placement. La 11e session de la Raw Academy s'ancre dans les réflexions ouvertes dans l'état des lieux 5, les sens du lieu, déplacement, replacement, non-placement, un symposium international conçu en collaboration avec le professeur Felminsa. Dans cette continuité, cette 11e session de la Raw Academy est partagée par des fellows et des facultés qui ont en commun ces préoccupations et dont l'expertise sur ces questions est reconnue. L'anthropologue et historien Abdurrahman Sek, l'architecte et anthropologue islamique Kofi Agbojinou, l'historienne et commissaire d'exposition Samia Henny, l'historienne antidisciplinaire, activiste et organisatrice sociale et politique, Dr. Sonia Vaz-Borges, la chercheuse designer et professeure d'architecture Mae-ling Lokko, Ali Betta, musicien, commissaire d'exposition, cinéaste, écrivain et fondateur de Kenu Laboratoire des Imaginaires et artiste et un chercheur, un innovateur, ingénieur de la social impact Kudus Onikeku ainsi que l'ensemble de l'équipe de Raw Material Company.
Alors, pour cette session, on a 10 fellows parmi nous. On a Abdelrahman Adja, photographe et cinématographe basé à Marrakech. On a Aïcha Alioubima, curatrice, autrice, chercheuse et photographe basée à Abuja. On a Amabi, qui est une artiste ghanéenne tissant son existence entre les États-Unis et l'Afrique de l'Ouest. On a Fogame Cornelius Raffin, qui est un nomade académique avec des formations en sociologie, relations internationales et travail social avec les origines camerounaises basées à Berlin. On a aussi Foueta Morto, qui est géographe, écrivaine, artiste visuelle ghanéenne. On a Lauren Lois Dua, qui est artiste designer transdisciplinaire ghanéenne dont le travail se concentre sur les façons dont la créativité, l'artisanat et les designs peuvent être utilisés.
On a aussi Younes Ben Slimane, cinéaste origine de Tunisie, travaille sur l'architecture vernaculaire tunisienne. On a Zezlele et artiste camerounaise originaire de Douala, Massaoka, et un photographe et réalisateur sénégalais né à Saint-Louis. Catherine Annabella Lee est une artiste antidisciplinaire, architecte, chercheuse, éducatrice et boulangère indonésienne basée à Mexico. Et finalement, on a Eugénie Shah, notre observatrice pour cette section, et écrivain et est une artiste pluridisciplinaire.
Et avec nous ce soir, on a Dr. Mae-ling Lokko, qui est professeure adjointe à l'école d'architecture de l'Université de Lille et au Centre pour les écosystèmes dans l'architecture. Elle est également la fondatrice de Bioregion à Accra, au Ghana. Ses recherches portent sur le développement du cycle de vie complet, la conception d'infrastructures distribuées et les politiques relatives aux matériaux non toxiques et à faible teneur en carbone. Dr. Mae-ling Lokko a précédemment enseigné à la Cooper Union et aussi à Rensselaer Polytechnic Institute, où elle a été directrice du programme des sciences du bâtiment et professeure adjointe à l'école d'architecture et au Centre pour l'architecture, la science et l'écologie. Ses travaux ont été exposés dans le monde entier, notamment au Musée d'art moderne de New York, au Musée du prix Nobel de Stockholm et au Musée du futur de Dubaï. Ces recherches ont été financées par le Programme des Nations Unies pour l'environnement, la Fondation SOM, l'Institut REARC, le British Council, le Global Architectural History Teaching Collaborative du MIT, la Fondation LUMA, le programme Nexus Clean Energy Accelerator de la NICERDA. Dr. Mae-ling Lokko est titulaire d'un doctorat et d'un master en sciences du Centre pour l'architecture, la science et l'écologie, et d'une licence de l'Université de Tufts. Elle siège actuellement au conseil d'administration de l'International Living Future Institute et de l'Architecture League de New York.
Aujourd'hui, Mae-ling présente Heutagogies planétaires, concevoir des matériaux pour la santé des sols dans la Bioregion de Saint-Louis. Les matériaux de Soil Sister seront explorés dans le cadre d'un modèle proposé de Heutagogie planétaire pour un apprentissage et une collaboration ancrée dans les territoires. Contrairement aux pédagogies conventionnelles qui instaurent une dépendance unidirectionnelle des étudiants envers l'expert, l'approche heutagogique met l'accent sur la conception d'un cadre basé sur deux projets. Réunissant les acteurs de l'environnement bâti des agriculteurs et agriculturistes, des designers, des fabricants, des bâtisseurs, jusqu'à habitants, afin de repenser et redesigner activement les pratiques interconnectées autour de la santé des sols. Lokko présentera 4 projets explorant l'approche des Soil Sisters à la croisée de l'agriculture, de l'alimentation, de l'architecture et des pratiques textiles qui forment la base d'un futur projet collaboratif de Heutagogie planétaire à Saint-Louis au Sénégal.
Donc, sans plus tarder, Mae-ling, thank you for these past 2 days with the fellows. And just a little reminder, please, if you need translation, we have some, so that you can be able to follow the conversation, especially with the Q&As as well. All right, thank you.
Good evening, everyone, and thank you for joining tonight. I have to admit, I wrote that abstract a while back, so it might depart from it a little bit. Mainly, it's going to be a background and almost a meditation on the work I've been doing that will link to what we're doing in Saint-Denis next year. What began as sort of a journey trying to find the use for a husk, coconut husk that was thrown on the roadside in Accra, where I come from, began a 15-year journey with plants, understanding their homes, what they tell us about our ecology, the different resident communities found in soil, and even the things that can't make their way back to the soil. And so I'd like to begin with, thinking about plants as our ancestors that have taught us to live on the planet in many ways. They've lived on this planet for a significantly longer time than us, with evidence suggesting that they've emerged over 500 million years ago. The first of them were soft, marine, green algae that really prospered in water. They weren't native to the land. But with the help of fungi, they developed over time roots to help them anchor onto the terrestrial rock that we find on land, and a sort of waxy skin that helped them conserve water. So the fungi helped the plants, and the plants very much helped us. And because plants could do something that we can't, which is take energy from the sun and carbon dioxide out of the atmosphere to grow, we have relied deeply on them for life. We as a species are nowhere in sight on this timeline. They've essentially been here 1,600 times longer than us. So not only did they come before us, but they outnumber us vastly in terms of size. In this seminal study that was done about 5 years ago, just weighing all of the life on Earth, you can kind of see that there is a predominance of plants on the planet. If plants were a building, they would be an 18-story building in the Tower of Life. They would be the main tenants. And we animals in orange would only occupy a single retail shop on the ground floor, with humans only covering the ceiling of that retail shop. And all the other kingdoms of life that are usually invisible to us, except if we're studying them, or they've affected our lives in a negative way, they outnumber us greatly in terms of carbon. Given their seniority and predominance, as well as the fact that they are rooted in place, we've developed an understanding of our planet from them. In order to understand climate around the world, we've looked to them as the best indicators of the dynamics of land, water, and air. In the higher altitudes, crocus flowers are the first bloom spring, giving us a heads up in terms of changing climate and soils. In tropical contexts, the multi-level architecture of dense tropical forests show us how older towering trees help store moisture and give life to many plant families below. And they work together to diffuse solar radiation and share nutrients. In drier climates, the desert flora teach us how to conserve water through how their form and their surface interact with the harsh sun and sandy winds. And so we built many of our homes with parts of plants for millennia. In tropical humid areas, housing was constructed with plant materials that had been trained over their lifetimes to deal with this high rainfall, high heat, and humidity. Palm fibers, local soft and hardwoods were used to develop structures that can withstand the tropical rain and humid air. And regionally, we've developed archetypes of that architecture that really look at making an embryo in the building with many layers of attics, verandas, lifting the building off the ground to prevent heat and to evaporate as much heat as quickly as possible. In the Scottish Highlands, we see the architecture of the Black House, which prevents the homes from, insulates the homes from the harsh, really cold and fast-moving winds from the east, from the North Pole. And in here we see soils that are sandwiched between stones. And we literally take the grass and soil off the ground and put them on our roofs in order to insulate us. In places where we may not even have land, we've used fast-growing plants to essentially form the foundations. They literally become land. They're also used to make walls and roofs, as well as watercraft. And these materials, which are incredibly vulnerable and weak on their own, when bundled together, can be used in a diversity of ways to form animal habitats. Over the last, I would say, 20 years, there's been a shift in sort of our bringing back plant-based materials into this mineral-dominated world with concrete, glass, and steel. Whereas all of the indigenous and traditional forms of working with and living with plants may have dominated millennia, we're seeing sort of a huge dependence on minerals, glass, cementitious materials, concrete, reinforced concrete, metal, that have been used to build our cities. And what has been projected through global policy, as well as a whole range of shifts in the built environment, is this return back to low carbon, healthy building materials. But it's been very concerning for me, the fact that we haven't necessarily changed our value system around the way we extract and transform materials. If we think about value in the world today, when we extract from our land and our ecology, that value is transformed typically through primary labor systems, whether that's a farmer or a factory worker, that add value to that material. Most of that value is sequestered by the owner when it's sold to consumers. And often, because we do not value these things enough, once we've used them, typically one short lifetime, it ends up somewhere in our landfills in terms of waste. And we see this in many regards, and we talk about it in terms of alienated value. And that could be farms, land that is exhausted, that has been extracted from far quicker than value is returned to it. It can be farmers who are not given enough value for the work they put in caring for our land and our plants. It can be factory workers as well who work in intolerable conditions and may not even get back the value, again, that they bring into the transformation of goods, all the way down to the end of our material life cycles, where we see a growing number of materials that are incapable of making its way back into the environment, into the soil. And so this sort of top-down extraction of value, in a sense that has been alienated, distanced from its generation mechanism, is what has driven the capitalist engine. For me as an architect, we have occupied this position somewhere between owners and consumers, in many senses driving and exacerbating that extraction cycle. This is a business model that has not changed for a very long time. And in the work that I do, this term generative justice has come to guide the way we work, which is really about working in the bottom half of this framework, essentially driving the bottom-up creation of value, the generative part, and I'll talk through a few projects that talk about generating value, and the circulation of value, which has to do with the justice part. How do we equitably distribute all of this new value back to its generation mechanisms? And Planetary Heutagogy has sort of evolved because of this sort of growing gap that we've seen between policy that is happening on the top half and what's actually happening on the ground. And it's very much something that's still in development, but it's trying to understand how do we work, rethink the structures that we find ourselves within, whether it's the university, the industry, enterprise, or it might even be the museum, where our work circulates and are involved in the production of capital. In many senses, heutagogy is different from a pedagogy in the sense that there is this belief that the skills and the competencies and capacities of all these different actors have value. And how do we shorten that distance and essentially develop an activist way of working together to understand how value can be rethought in that framework? So it's very much a knowledge sharing framework, and it does rely on a certain level of competency and skill in terms of students who are part of that framework. But it is interdependent, and it was also self-determined by that community. So how would you design differently when a farmer and a fabricator come together? All of them participate in the same material life cycle, but don't necessarily make decisions according to how the other might touch or transform a material. And it very much changes the role of the teacher. It is not necessarily a one-way transfer of knowledge, but it's very much a facilitation of all the different students' capacity to learn. So in this framework, students really take responsibility for creating their own learning pathways, and they go beyond problem solving by enabling proactivity. Learning by doing, it has been something we've been crafting, so the act of building is incredibly important in this framework. So I'll talk a little bit about some of the challenges we're facing when we're rethinking the use of these materials. Every time we develop a material, the next big question is, how do you scale it? How do you scale it? And for us, this is not something that is not political with huge disastrous consequences. Last year, we launched a major United Nations Environment Program global report that took a survey of all our building materials on the planet today. And the goal was to sort of set the agenda, to really bring building materials onto the climate agenda. So there was a projection between now and 2060 that bio-based building materials, materials coming from plants, will form half of everything we build with. And that's incredibly controversial, mainly because if we look at the ways we've scaled plants in the past, they are incredibly problematic, and in many senses may exacerbate some of the impacts we see today. This is a survey of the world's most widely produced agricultural crops and their byproducts. And you can see historically this has been dominated by the big four: sugar, corn, rice, and wheat. And now there's the emergence of soy, the fifth little sister. And in many senses, we started to work with a material that is not at the top of this, the coconut, which I'll talk about in a second, because of what it was made of and how it could be instructive in terms of how we transform plants. But when we look at the first, sugar, the most widely produced crop throughout our history, we've seen, how an innocent wild plant grown on riverbanks in Papua New Guinea has become the most predominant plant on the planet today. Taken from Papua New Guinea to mainland China, the Pacific, and India, it has been used by empire, the Ottomans, the Portuguese, the British, and spread, all over towards the Mediterranean, to Italy, and then makes its way around Africa. There was a seminal moment in the history of sugar in Madeira, an island off the coast of Portugal, where the monoculture was invented. And here we see this pattern of killing every other plant except one, clear cutting, and the large-scale growth of a plant in a controlled timeline, necessitating, when we have a plant that is incredibly impatient, like sugarcane, after 48 hours you do not crush it to extract the juice, it begins to rot. And so that system and that personality of the plant requires this large-scale labor force. And so we see enslaved Africans being brought to this island, to farm this plant at scale. And this has led, to a system of labor that was warranted by this monoculture in order for it to propagate and drive the capitalist engine. We've also seen how of this fringe spice, which is what sugar was used as, and even as a medicine, has become globally consumed and the underbelly of that economy. And in many senses, when I started working with coconut, we thought we were doing something good. Coconut, in many senses, follows the super crop history of sugarcane. It's been a friend with us for a very long time. It's used as food, fiber, filter. It's a portable source of food and water, and so they've played a critical role in enabling humans to voyage and establish trade routes around the humid tropics and beyond. And in the last 2 decades, the world has really caught on to all of its uses. Fueled by global marketing campaigns and health trends, the coconut and all its primary derivatives, but oil, butter, milk, sugar, water, have really become elevated to superfood or supercrop status. In order for this boom to be satisfied, we see the growth and generation of all of these byproduct materials, what I like to call the underbelly of the coconut industry, that are being produced all along the equatorial belt, 23 degrees above and below the equator. We started working with this husk, and when you break it down, it's composed of 2 things, a fiber and a dust-like substance called pith. This husk is in many senses something that is, there's no place for it, in the city. In Ghana, for the last 20 years, it's illegal to dump coconut husks in waste municipal systems because they form these huge land compaction problems in landfills. They literally ruin compacting machines. And so coconut traders who sell these coconut water in cities pile them high on the roadsides or in larger mountains close to the city, and they burn them at night. And so what begins as a land pollution problem quickly becomes an air pollution problem. And for us, it was important to engage the coconut trader as a collaborator in this enterprise. The husk is the symptom of a much larger approach to agriculture that is seen all across the world. We are intricately tied as a species to the growth and production of this agricultural waste. About 5 years ago, we grew close to 10 billion tons of crops to feed ourselves. But often, as much as 40% is actually lost somewhere between the farm gate and the plate. And often we see these materials being prematurely burnt or downcycled before they've even had a chance to show what they're capable of. And so over 10 years, we studied this wide spectrum, these different pathways of the husk, from the more dense, mechanically strong applications, things that can replace plywood, fiberboards, all the way to materials that are incredibly light, very good at absorbing moisture and chemicals, small chemicals in our air. And that's always a trade-off. Unlike concrete, glass, and steel that have very small specific uses, natural fibers have thousands of uses. They're used as textiles, ropes, insulation, as well as building materials. And so we've used them in a number of projects. Here in Accra, we used it as a soil substitute. So in one of our last remaining public parks that is constantly flooded during the rainy season, we created a bioswale, recomposing some of the soil layers with coconut pith because it can hold such a large amount of moisture relative to what it weighs. And so here it captures and slows down moisture and holds it for a range of flood-tolerant plants like indigenous African rice to increase the water storage in cities and deal with flooding. We've also explored it as a building material, and what we discovered was the pith that was already found in the husk when pressed at a certain temperature and pressure, much lower than what we use for creating plywood, it melts into a very uniform glue in the board. And so in essence, you don't need any type of synthetic and toxic glue. Everything is actually found in the husk itself. We've also explored it as a composite, so the insulative coconut fibers and the pressed fiber boards as becoming an insulative roof or facade, particularly in informal settlements where in those spaces it's incredibly hot during the daytime because of all those metal sheets that transfer a lot of the heat from our sun. Just insulating the roof can bring down heat gain by 70%. And what's wonderful about these fiber boards and the architecture of the pith and the fiber is that it allows the materials to breathe. And so here you can see a sort of pattern in the early hours of the morning, this absorption of moisture in the indoor air in the house, that exhalation during the hottest part of the day, and again and again. And this produces an insulative effect, buffering all of that heat gain, because all of the moisture that is held within the material takes on all that heat, and then produces an evaporative cooling effect, something that we've seen over and over again when we're in a thatch or fiber space. These materials perform that over and over again. We've also looked at how to increase its value, because pressing these materials into a flat board might get you to sell it at $2 to $3 a square foot. And relative to all the labor that is involved to transfer this material, there's many other things designers can do to improve or increase that value. And so using that same amount of material and embedding form, surface texture, we started looking at acoustic panels that would enable these materials to move from $2 to $3 a square foot to $40 to $60 a square foot. It was important for us to show this work, first in West Africa, in Ghana. And so the Chariwate Festival in 2016 is where we showed this material, particularly because the social perception of these materials in places like Ghana is really negative. It's very hard to convince people to build with natural materials for many reasons, which we can discuss. I know the girl in the middle is not looking very impressed, but I took the photo at the wrong time, I think. But there was a lot of interest, particularly from masons and carpenters. We also looked, and I'm just showing the spectrum of pathways of these materials in the building, of using these materials for improving indoor air quality, which is becoming a huge problem in our cities. Opening the window for fresh air is no longer means that we're letting good air in. Our outdoor air is heavily polluted. And so we started looking at these materials as participating within environmental control systems, where we have partition walls, ceilings, and walls where we can actually bring indoor air in, clean it, dehumidify it, and bring it back into the same room. Coconut activated carbon, coconut pith, coconut fibers are fantastic at doing this. And so you can see here it operating in conversation with the HVAC system using very small sensors to control air and a way of distributing them to improve air quality. And so this idea of value generation through design, from the flat board to the acoustic panel to the environmental module, are that part of generative justice that designers have a huge role to play in. However, that translation of value is incredibly important. There are many actors we're bringing into the table, whether that's valuing the work the land does or the tree does to condition that plant. We might be bringing in new players like waste managers, coconut traders, new eco-manufacturing enterprises, all of which need to be valued in terms of their contribution in order to circulate that value more equitably. We also started to look at, in response to promoting the coconut monoculture, how we might explore new paradigms of biodiversity. Could we design to encourage multi-cropping systems back in the farm? And in many senses, this came as a mistake. So when we started working with coconut, we were working with very old coconuts in the western region in Ghana. Mainly they were grown for coconut oil. But most of the coconuts that is available in the cities are grown for coconut water. So no coconut was ever created equal, we found out the hard way. And so we started to see, are there other binders that are more standardized that are coming out of industry, like soy waste, or fungal mycelium, that was a binder made from the vegetative state of fungi, mushrooms, that could also feed on the sugars in the coconut husk and produce boards. And mycelium for me became a really important technology because it didn't have any preference in terms of what it ate, this strain. It would eat corn, coconut, hemp, flax, canola, and produce, what you see in the middle. I like to call this a Kit Kat. But in the middle, this is corn-fed mycelium. And all of a sudden, we could use many things growing under the coconut tree, whether it's corn, whether it's the fungi that grows on the corn, to collaborate and not necessarily just rely on the coconut husk. It's also very expensive to make a panel just out of coconut husk. They're also incredibly heavy. And so having that light sandwich in the middle was really key. So it's a collaboration of many different bio-based materials in this panel. Fungi for me became incredibly important. It does not require any energy to grow. You're just putting a cover over it and feeding with agricultural waste. And over the course of 5 days, it used to be 12 days, and we got it down to 5. It grows into this sort of styrofoam-like material. In France, we worked with the Luma Foundation. We started their fungi research unit and started to look at all of the crops that were grown in the Camargue region, because 40% of all the country's organic produce is grown there. And so here we could expand not just from agricultural waste, but to food waste, as well as invasive species, things that are growing really quickly, particularly on borders of water and land. And we could mix and match according to the seasons so that we weren't relying just on one plant. And so we developed a prototype project in a community kitchen in Gufoy, which is just north of the Luma Foundation. And we started to look at all of the byproducts coming out of the community farm. There were a lot of North African farmers, Senegalese farmers, that lived in this area and farmed in quite a large scale. So a lot of the agricultural waste coming out of the farm were used to create these acoustic panels in the kitchen. And the smaller quantities of food waste, whether it was garlic skins, lemon peels, onion skins, were fed to create more niche products that were made from objects in the kitchen for holding cups, utensils, plants, things that could go in much quicker and allow people to experiment with microcomposites. In my practice as a professor, we also experiment with building larger structure made out of mycelium. Here it is in the Sonspeak Biennial in 2021, in a forest where we used agricultural waste and mycelium from a beech tree forest where honey mushrooms grew under. And mycelium can really take the form of everything from a tool path that is used to generate the mold. So we typically make a mold using conventional methods. We form what is called a plastic grow tray, which can be reused again and again and again. All the agricultural waste is inoculated with that liquid mycelium, and it grows in there over 5 days. And it's interesting to come to a mycelium factory. You don't have loud, screeching metal machines. It's very quiet, and it smells like mushrooms, which I'm sick of. But it's a whole range of agricultural residues that you become very familiar with and are able to identify. So my plant literacy rate went up by quite a bit when I was there. And here it's used in an installation in Z33 in Belgium, which I'll talk about very briefly later. And lastly, we started to also think of what is the value that we are ascribing to these materials. And a lot of this work came out of working with the textile industry. In Ghana, my company was hired by a fantastic company called Global Mamas. They were 6 women who would, in their homes, make high-quality textiles for export. But they've grown to 600 women around the country, and some of them have come together to produce textiles to make use of economies of scale. But one of the byproducts of coming together and dyeing is really toxic wastewater. And of all the options that are available to them, they were very expensive, a lot of aluminum and iron-based chemicals that are very harsh on the skin, but are also incredibly expensive and toxic once they're let out into the waterways. And so we started looking at moringa, which is something my dad used to tell me. His mom would make him soak his hand in water with moringa to clean his fingernails. Its cleaning properties have been something that has been used not only in West Africa, but in South Asia. And so we started working with its waste, the pressed meal. So it's actually the ground up version of this that looks like flour. And it's an amazing flocculant. It makes all the bad stuff clump together and settle. And so you can see here, after a year of research in the Ghana Water Company labs, the impact of some of the moringa on some of the worst dye recipes, like the blue blacks, the multicolored dyes. After 6 minutes, you see all of that sink to the bottom, and you get water that is well below the EPA required levels. And that sludge is also a problem. What are you going to do with that? And so we also started to think of it in earth masonry, as compressed earth blocks, as ramped earth, to also make use of that sludge. But I have to say that, when the Global Mamas centralized, they built their own factory in the Volta region in Ghana for 200 women. They just took that system and just multiplied it. And so when I visited the factory for the first time a few years ago, when you see the scale of sludge that is being produced, it gave me a heart attack. We suddenly realized that we were not necessarily solving anything, we were just treating the symptoms of a very toxic system. And what we really needed to do was to go back and redesign the dyes that we were working with. It also caused me to rethink what is the ultimate goal of all this work. And we started to center soil health. How do we return that value back to the land safely in a non-toxic way? With that as the end goal, how would we design materials differently? And so that's given rise to what we call soil sister materials. And there are a broad range of biogenic, mineral, even synthetic materials, because we don't have the luxury of not dealing with those materials anymore safely. So very much in contrast to the bio-based materials that really prioritize where materials came from, soil sisters really think about where materials are going in terms of timely and non-toxic degradation. So I'm going to go through very quick examples of this. In particular, the range of research we've been doing, but also an approach in my work as an artist, where I've sort of used the art space, art platforms, biennials, as an opportunity to shift the narrative and meaning behind these materials. And my method has really been around finding these symbolic spaces of extraction and reconstituting their materials with soil sister products. So the carbon sink is really embodied by the coconut story. Instead of releasing all of that carbon into the air by burning it or composting it, allow it to actually be stored in the building for a period of time. And so we're delaying the carbon emissions, but we are making use of it as shelter before. And so the biggest problem we're finding in all of the work that is happening around bio-based materials is the fact that we use really toxic glues. In the UN report that we published last year, we actually found out that laminated bamboo products have the carbon emissions of steel because we are doing all sorts of things to it, chemical treatments, drying it, shredding it, pumping it with glues and synthetic coatings. And we like to say Botox. We like to Botox these materials so they don't age, they don't move, they don't breathe, and ultimately form huge problems at the end of their life. And this project, which I walked through, one of the exhibitions called The Door of Return, took the symbolic figure of the door of no return that many of you have probably seen here in Gore, but that line many slave forts along the coast of Ghana. Growing up, I visited every single fort, which is a lot because I don't think there's any other West African country that has more than 10 slave forts, and Ghana had something like 43. What does that say? So this image has always been seared in my mind. It was a very heavy threshold, architectural threshold, and the view was always out looking at the ocean. And in this piece, it was self-reflexive to look back on land, to really look within, and to rethink the materials of the fort, which were consecutive histories of Dutch, Danish, British bricks, which have their distinct colors and tectonics, and rethink that with the coastal materials of the coconut. And also show that materials don't have to last forever, that there are ways for them to slowly return back, to the soil. The material bank, and this was very controversial and difficult for us to get on board with, but given the fact that we have reciprocal landscapes here in Africa, all of the material that we export, low value, and import all these materials, high carbon, super toxic, and value added, end up on our shores. And those materials are things we have to deal with given the scale of them. And so we started working a lot with textile waste producers, recyclers, in Ghana. Ghana is the world's second largest importer of secondhand clothing. And again, looking at the binders that are used within them, as well as how to reduce the energy that is used in the production of these materials. So here you can kind of see a range of furniture, fiberboard, acoustic panels made out of textile waste. Non-toxic circular, because we can talk about circularity, but what type of circularity is it? Often it's toxic circularity. We use cement in many materials that don't enable them to be recycled. So microcomposites has been a big area of research for us. But in many senses, mycelium technology is entrenched in a very high carbon economy. It's also a monoculture. The strain of mycelium that's used all over the world for growing packaging and for building materials is one single strain from upstate New York. When I bring it to Ghana, it molds. And so the idea of diversifying mycelium, especially using mycelium from where it's grown, feeding it with food it likes, can do a lot to address the whole host of possibilities in mycelium. And also it relies on the lab infrastructure. You're refrigerating, you're sterilizing these materials. And you're using plastics. And so looking at other alternatives for growing mycelium has been a huge aspect of our research. Here, this project in Liverpool and in other parts of Europe have been an opportunity to work with urban farms to really think about a distributed infrastructure for microproduction. So instead of copying the agricultural central model, how do we actually transform these materials closer to where these wastes are produced? And so in Liverpool, with the Royal Institute of British Architects, we essentially grew with 200 people ranging from middle schoolers to elderly urban street farmers, a sort of kit for growing mycelium. And so the scale of the grow tray is very much on the scale of the human. You can hold it, you feed it with additional nutrients from your kitchen, and they grow in molds right on site. So these workshops that citizens participated in occurred throughout the city and in different schools, and was grown right on site in what we call our mycelium construction site to form the eventual architectural construction at the opening of the gallery. And here, the mine, again, is a symbol of extraction, was what we built, but recomposing that mineral material with mycelium. We've also worked with earth masonry, replacing cement with agricultural waste, fly ash, agricultural fibers that can also improve its strength while reducing cement, so that circularity tradition can continue. Here, we were hoping to build a studio from for an artist, Ellen Atsui, the sculptor in Ghana, his studio, all out of earth and masonry. And we hit a wall because no contractor was willing to take on this job because we had to build this in 6 months. It's a huge artist studio space the size of a football field. But we were able to help a contractor sort of scale up the production of earthen blocks, at least for the central artery in the studio, which forms sort of a street right in the center, and the ventilation of which allows the entire building to be non-air conditioned. 2 months ago, as part of the Venice Biennale, we brought all of these materials together in an installation, Vina Cava, which looked at the greenhouse in the Palm House in Kew Gardens, again, as a symbolic site of extraction, but recomposing the metal frame and glass panels out of a collaboration of material bank, carbon sink, non-toxic circular materials. So here you see rice-fed mycelium. You see geopolymer panels that are made out of recycled solar panels, ferrosilicates that are byproducts from the metal industry, as well as a range of agricultural residues, rice husk, all the way to fly ash, that give all of these different panels a blue, red, or sort of charcoal black hue. And so for us, the collaboration of these different materials generated a very different type of paneling system in the installation. And it also spoke to the multiplicity of approaches that we need today in order to address soil health. In 2 weeks at HKW in Berlin, we'll also be showing a different version of the greenhouse, this time modeled after Berlin's Treppenhaus, but instead integrating the textile waste that's gathered from the coast of Ghana near Kantamanto Market. And here an entire vocabulary of textile, geopolymer, and fungi panels tell the story of contamination, because our soils are no longer what they used to be. They are composed of a whole range of materials, including plastics and textiles. And lastly, I'm going to end with where we always hope to go, which is regenerative approaches to materials. And by and large, we've been doing this with plant dyes. And so we've been looking at creating new types of colorings for building materials, because often color is a huge source of toxicity in the built environment. When we paint buildings, we are literally giving a source for off-gassing for many years to come. That concentration never truly decreases. It's a very toxic indoor environment that we're breathing in. And so dye baths, earth renders, literally embedding some of the colorants into earth masonry, as well as other types of toning, help to shift not only the perception of these materials, but their performance over time. We have in many ways been inspired by culinary practices, because in studying a plant, similar to how a chef understands a cow or a sheep, they know and have a name for every single part of it, and they know how to cook it in order to make the texture, the flavor, and the experience of that part delightful, for someone who eats it. And in that sense, we also have to do the same thing with plants. Understand what color comes from a root, from a stem, from a leaf. They're very different colors, but they talk to the history of that plant. So in collaboration with a leading plant dye expert, Sasha DeWare, we've been developing what we call a plant tone catalog. As opposed to Pantones, we have plant tones. And it shows the versatility and wide expanse of plant world color. So a single plant, depending on when it's harvested, can give you very different colors. And that in combination with the type of natural mordants that you use, you can shift color in a range of ways. This from 2 years ago, the summer of 2023, with some of my students in Ghana, we took 8 Ghanaian plants and lateritic soils and developed the full color spectrum from the reds all the way to the blues. And sort of here is a shot of the exhibition where we dyed, some of the textiles from the market with these eggplant dye baths, some of which are in combination with each other, again, which generate a lot of versatility in the range of plant tones. And I'm not going to go through all of it, but you can find it in our Soil Sister library. Ultimately, what we hope is to create a platform with all of the recipes that match Soil Sister products to different contexts. So these are all place-based, and are also developing building materials that are also place-based. Ultimately, the design of soil health is really an intersectorial and an ecosystem design project relative to the sort of contemporary material paradigms where value is generated solely at harvest, multiplied at points of sale, after which that value slowly decreases throughout its first life. This sort of integrated life cycle approach can really drive new metrics, including that of soil health, where value is created at strategic points across multiple material lives. And ultimately, value is measured around how the proportional use, its life cycle timing, and its whole life cycle contribution results in soil health. So I'll end there and happy to take any questions. Thank you. Yeah?
Can I ask it in English or in French? Which one is better?
English, if you don't mind.
So thank you very much for the presentation. My name is Saman Mehdi. I work on climate, space, and art, so I really love the way that you mix both of them. And my question is, from all of the studies that you made and the material that could be applied to the construction industry, according to you, what is preventing it from being scaled in the industry? And if it is about the cost, according to you, what could help for reducing the cost of those materials? Thank you.
Yeah, no, I think on the supply side, yes, it's a question of cost, but we've seen how many materials make use of economies of scale through very capitalist models. And ultimately, I think that there is a compromise to be made. I think that some of the biggest players in shifting to bio-based materials might be the very people who've profited from it, the existing cycle. So, for example, all of the problems we've had around quality control, the variance of natural materials, we need time to build up that consistency in the industry, and that can only happen if there's investment and there's a reliable client. It may not get us to the product we want right now, but there might be a near to far-term approach. So for us, using agricultural waste, converting it into fly ash, and using that to replace cement might be a near-term collaboration with cement companies. And it would buy us enough time to build the types of equipment that we need, because Tifa fiber, coconut fiber, all of them need very specific machines. They're very different plants. And we need that investment and that time to scale up. It also means that all of the intelligence and capacity from cement workers, the amount of people who work in the cement industry in Africa and the global south are so many, and there needs to be time to transition, that workforce to, for example, earth masonry. So on the supply side, I think there's collaborations needed there, and we can't have startups taking the brunt of all of this on their own. On the demand side, I find architects and contractors and everyone in this work are only focusing on the supply side, but we're forgetting about demand. Do people want these materials? And this is where I feel design has a huge role to play. We have to show through projects everything from breathability and comfort But I find, frankly, what gets people into the room is customization. People want to express their identity. And so I think it's why we spend so much time on the aesthetic and the customization through color part of this, because we know that's what will get people on board. And I never thought I'd be saying that, frankly. When I showed the Kaguna panel to clients in Ghana, they're like, can we paint this white or gold? And I'm like, God, do you know what we're doing here? Like, you know, so I think customization is really part of an aspirational project, and I think we need a lot of work. It's deeply seated, and we also need a lot of research around, you know, some of the deeply seated perceptions of these materials. We know how to design these materials to deal with fire, absolutely, but I think it's the other stuff, like, you know, historically we've seen cities razed to the ground with fire, you know, as part of the colonial project, and I think we need new narratives around these materials. And again, I think that's in the work of the cultural space, you know. So, yeah.
Thank you, Mae-ling. Obviously, we've been having a lot of conversations around all of this for the past couple of days, so it's been really great to find out more about your work. My question kind of relates to the one before, but it's around how does research and engagement through art and kind of like experimental research, like the things that you've shown around waste and bio-based technology translate into actionable policy? So just a question, especially in the case of Ghana, how are policymakers responding to some of the research that you've been doing and showing?
Yeah, oh my God. I think the UNEP project was the first time we truly decided to engage policy. And it was in collaboration with Senegal and Ghana team. And we chose these two contexts because they represent, it's not Lagos, it's not Nigeria. They're medium-sized countries with relatively stable economies. And we felt there was also enough of a contrast in terms of architectural typologies that we could do something that a lot of regional countries could take from. And so the first thing that we tried to do was engage existing work. So there has been work by CSIR in Ghana, which is our national sort of research branch, as well as some pretty awesome people here who are doing research in the built environment. So we looked at the most prevalent housing typologies, and we started to look at what if we replaced some of the mineral-based systems with bio-based or earth masonry. So it was a survey, but it was also showing what was possible and not forms or buildings that were completely foreign, you know. And we have a second project where we're showing the full potential. How could we actually implement low carbon design in projects that had not been built or needed to be retrofitted? And because there is quite a strong push right now from the global front on national government policy, we found there's just a lot of interest and collaboration from government actors. But we really need governments to say, hey, we are going to be your first clients. We're going to require all government buildings are built out of this material and in this way. Because often if they take the lead, we see many other projects following suit. But I think ultimately the biggest industry players have to be the people we work with. If you look at most UN reports, they're funded by industry. Like, you know, and so it's also a thing that we need to do in these projects. How do we engage everything from plastic to cement to even timber companies in terms of leading the way? It might mean that we target certain materials or chemicals they're trying to phase out and replace them with bio-based, low-carbon, non-toxic stuff. But that's something we haven't gotten to yet. So next year, the project in San Luis is an opportunity to do that in a bottom-up way, but bring all these different stakeholders to the same table including policymakers. For us, it felt like a way to, not be stuck in a project, an elephant project for the next 5 years, and in many senses that would scale in a way that we couldn't necessarily influence. The idea was that we train people in a neighborhood how to do this. Monday you learn how to do roofing, slabs. Tuesday you do clay paints, and it's the neighbors that will teach their neighbors, not us. We think that model will probably scale much and diffuse much better than a training program that is only available to few. So we'll see how it goes. I guess 1, 2, 3. We'll go back and forth. Okay.
Thank you for this fulfilling presentation. I'm Senegal, coming from Lagos, Nigeria, and despite of the ecological benefits, plant-based material are seen as low tech, low whatever. So I know you answered a bit my question, but just to go deeper, how can we switch this perception? This is my first question. And the second one is, I would like to know what is the difference between heutagogy and heuristic pedagogy. Thank you.
Heutagogy and heuristic?
Heuristic pedagogy.
I don't know what heuristic pedagogy is. What is heuristic?
That takes every kind of subjects when it comes to teaching.
Oh, I don't know. You're gonna have to teach me about the second one. But I mean, I think from a pedagogy versus heutagogy, still, I think a pedagogy assumes that there is a teacher with the knowledge, and there is somebody who's going to learn. It's very much a one-way transfer. And a heutagogy is, there are moments of pedagogy in a heutagogy, but this idea that learners have something to contribute and play a role in self-determination of their education. So I think that we're still experimenting with the heutagogical approach. But, I think, for example, I think about the knowledge that crafts people have, masons have, but because they don't have an official certificate, a professional degree, that the balance of power and who gets to make these decisions is never always, equal. And so how do we allow a framework for different types of knowledge to be valued, equitably in order for the design of something to emerge? And then the first question was about the perception.
Yes.
I don't know how else but to show in projects that these materials are strong enough. I mean, we publish, we build with them, we design with them, to seduce, to open the conversation. But I don't know how else. I feel like buildings are so slow, and we learn from buildings in a very, very slow manner. Like, you build a house and then you sit in it and you're like, actually, I see why they said not to do that, And same thing with these materials. It's only when you're sitting in your really hot house, and you go outside and it's actually cooler that you realize, I should have done something different. Maybe that material would have worked better. So I think it's a matter of creating experiences where people can truly understand and we can sufficiently capture the value of these materials. And then talk about them in different ways. But I think this is where art, and artistic practices can really go the distance. It's hard to do this in a lab and publications that nobody reads or catalogs. It became very stifling for me, which is why, again, I turned to, exhibitions. But I worry now that the work sits in luxury, high-end spaces and don't necessarily make their way to the places I want to see them in. And this is sort of why this urgency to learn by doing and these build projects. But yeah, just from my perspective, I think art and a range of artistic practices are needed.
Bonsoir, merci. Moi, je suis scénariste et documentariste discutant. J'ai écouté votre présentation, super bien, sur le fait que ça a passé dans un état matérialiste, capitaliste, je disais. Oui, quand on voit un matériau de gaz qui va être transformé pour autre chose, vraiment, je me suis dit que ce matériau a fait un pas vraiment dramatique. Prenons par exemple le noix de coco. Le noix de coco, quand on l'utilise, on n'en a plus besoin. Ça peut créer des blessures quand on le jette comme ça. Mais bien avant, ces noix de coco sont utilisées dans les ustensiles, comme une pierre, comme un seau à boire. Mais pourquoi on ne donne pas aux artisans de développer ce travail-là? Donc le matériau lui-même, il n'est pas transformé, mais il est utilisé comme ustensile. Tous les matériaux, vous avez vu par exemple, les déchets agricoles, ce ne sont pas des déchets. Ces déchets agricoles permettent de recouvrir la terre afin de sauvegarder l'humidité. Et quand la terre chauffe, ça fait des dégâts. Et pour que cette terre ne chauffe pas, il faut qu'elle conserve son humidité. Est-ce que vous avez fait des recherches par rapport à ces éléments-là?
Thank you. No, it's a really good point, and it's also why the last diagram speaks to the fact that this work cannot happen without a much broader ecosystemic approach. We know we are growing so much biomass that often we have a load, right, on the land. In many other climates, this becomes a fire hazard. We see wildfires happening at larger and quicker rates because there's so much dry biomass. So I definitely think this is place dependent. In Ghana, we have a system called PROCA where we layer different agricultural residues on the soil in order to return nutrients back in a really timely manner. But often we're growing way much more than what that system needs. So there is an excess, and I agree the term waste is not, we really do have to do away with it. It's byproducts, it's co-products, it's residues after, the food is taken or used. But there is excess of biomass, and it's only going to get larger, relative to the amount of land that's growing it. But on your first comment, you have a huge point. I mean, the dominant paradigm has been to shred materials into very small pieces so that we can have control, over how the final form eventually, can fit within the way we build. Unfortunately, I don't have the luxury of not working within that paradigm to get these materials into buildings. But I think we can push how narrow standardization is in buildings. We can show how different materials can result in the kind of strengths that are required by building codes. We can show that we can use a multiplicity of plants or other types of materials to still achieve some of the standards, again, that we have in buildings today. But outside of the building, the building industry is incredibly conservative. I do agree with you. In culinary or other sectors, we may not have to process these materials to the extent that we're doing for buildings, the husk itself in its natural form, there could be ways to use it in a gabion wall or something. I could imagine that.
Je vais le couper un peu. Il ne s'agit pas de broyer en fait. Il ne s'agit pas de broyer le matériau, il s'agit de le tailler en fait.
Il ne s'agit pas de broyer en fait le matériau en fait. Il faut le tailler. De telle sorte qu'il devient utilisable. Si tu as un noix de coco, tu peux le tailler, tu peux en faire un statut pour 2 personnes. Mais ensuite, quand tu prends le Ghana par exemple, dans un village, il y a combien de personnes? Ils utilisent quoi pour manger? Je pense qu'il faut essayer de réfléchir dans ce sens où je veux.
I completely hear what you're saying. I think that there's a spectrum.
Il n'y a pas seulement, nous, la construction, on utilise souvent ce qu'on appelle l'argile. Donc pour les matériaux, les déchets comme des déchets agricoles, des plantes, tout ce qui vient de l'arbre comme ça, en fait. Cet arbre-là, il y a un moment où toutes les feuilles tombent. Les feuilles viennent. Mais ces feuilles qui sont tombées là ne sont pas des déchets, ils retrouvent juste le niveau du sol pour protéger les racines.
Completely understand that. I mean, we don't work with.
C'est un exemple assez bête, assez simple, assez bête. C'est dans ce sens-là que je veux.
No, I understand your comment and your question, and I think there's a spectrum of ways one would process these materials. There is the need to process these materials in some cases to stronger, high-density applications. You can even see that on this chart. I mean, the fiber mat is not processed at all. We're using it as its natural fiber. The pit, the dust, we're using it. We actually don't even compress, because when you compress, you change the surface morphology. But you have to match the processing to function. And I do agree there are ways that we overdo the processing, which I think the most extreme, is Botoxing these materials as opposed to making them breathe. But the matching to end use is so important. I agree with you that the sentiment is, can we reduce the processing? And if that's your point, I fully agree with that. But yeah, not really sure what else to say on that. Have I addressed your point, your comment?
On va prendre 2 questions. Si c'est des commentaires, on va en prendre juste une question. Et après, on va clôturer. Je pense qu'il y a une question ici devant.
Thank you so much, Mae-ling, for this presentation. I wanted to ask if you could speak a bit more to your work and research in Samuel with regards to the ecologies and plant ecologies specific to that region, and how you will see that it will inform the whole museum project and the materiality of that.
Yeah, we're sort of at the beginning, but last year we were partnering with RAW, and we had a month here in Senegal, which ended in Gandio. And so there are a few materials which we know we're definitely going to work with, and one is definitely the local clays. There's a fantastic tradition of even oxidizing this clay into a range of colors, black, red, yellow, which are also very much the identity of the clays. And earth masonry in collaboration with TIFA, that's really something that's being done here in Dakar and other parts of the country. but to make everything from compressed earth blocks as well as ceiling slabs, prefab ceiling slabs, which is very important. A lot of the roof conditions in many of the homes require insulation, but also structural improvement. Clay paints. We are trying to expand the range, and also because Senegal is a UNESCO protected city with its own requirements and protocols around, how the building looks, particularly from the outside. We're super interested in challenging, what some of these requirements are. We also will be working with salt. The second project will be a storage house for salt. Not only because the salt sort of sits covered by textiles during the day, but also flooding is an issue. So we will be building, with that material in mind. And so I think that's going to be really interesting for pushing, some of the requirements around the materials to deal with really salty interior conditions. How do we do that with bio-based materials? But I think those are the starting points. We're looking at all the other sister crops that are farmed in and around. We know there's rice farms close by as well. And hopefully come up with a range of products that match the scale that is available, but also, the demand for some of these houses. So, yeah.
Thank you for such a fantastic presentation. My name is Senegal, here in Dakar. One thing that you brought up on an early slide was how some of the early work with the structured boards. Initially, you had a price point of maybe $3 or $4, if I recall correctly, dollars. You also found that by doing some of these acoustic molded boards, it could move up to in the neighborhood of about $40 dollars per board. How do you think about the ratio between returning value to people in the value chain versus affordability for consumers who might be sort of bottom of the pyramid versus extracting as much value as you can from people who might be able to pay more?
Oh my God, such a good question. So when we were doing this work, there wasn't a demand for coconut fiber boards. There still isn't, I would say. And so our partners, Ecofibers in Ghana, they collect the husk from the local market in Ashaiman, and they need an export market to at least help drive some investment into the machinery needed to produce these boards cheaper. Because I think we were making boards initially at 2 by 2 square feet, which that's not a size anybody wants or needs. And so what they really wanted to move towards was a 4 by 8 sheet. So for them, the acoustic panel is the means to an end. Acoustic panels are very much in demand. They're also, they buy into this whole move now around healthy buildings, particularly in the United States and Europe. And so that was very much for an export market or a one-off project, with a wealthy client. But getting the materials down to a price point that somebody was building a kiosk could use. This is why I think coconuts cannot do it on its own. We need something else that's produced at a larger scale, or a mix of materials that can come in and out of production. And the coconut is only kept to where it's needed, really, on the surface. We don't even need it on the interior. So I think that economizing of the coconut fiber and then that insulative material, it could literally be textile fiber boards, as opposed to an agricultural byproduct. And that can get the cost down. We didn't find that having them on walls was the best place for them. We thought roofing structures that really help mitigate heat and that people do pay a little bit more for might be the way to go. But we haven't really pushed a ton on that front because I kind of became a little bit disillusioned with the thermal pressure requirements. I mean, I worked in the factory for a year, and I would say 75% of the time we had a power cut. You know, we could not press the boards. We were running on a generator when we did. And I think it was at that time that I realized we need to grow these materials with mycelium. And then I realized it's a mycelium monoculture, and it's plastics. And so I have to say, it's not been a straightforward journey. It's really, you know, we turn when we see a problem. And now the research on mycelium is now beginning to take off because we now have a wet lab to start to look at different strains. But we have strains on the forest floor in Kumasi in Ghana that never get infected in a humid environment. And it likes very specific food. And so it's that type of matching that I think might, you know, open up a new avenue for the work. There's mycelium that, you know, BMW almost replaced this car insulation with mycelium because they were trying to green the car, and they didn't because of smell. Because we like the new car smell. It's like basically VOCs blowing at our face, and we're like, that smells really good. But it's so difficult. I mean, I think probably everybody here associates the new car smell with just luxury and high class and just, you know. And so we started thinking, and when you're using mycelium insulation in a hot day in a humid environment, it doesn't smell bad, but it does smell like mushrooms. So it was a barrier we did not anticipate. And so in Luma, there was a strain that only ate the skin of beets, and it produces vanilla, the compound, aromatic compound. And so we thought, oh, maybe vanilla? But no one wants to smell vanilla 24/7. So there's a lot of work in the unanticipated, like, sensory parts, you know, of these materials, other performances that, you know, we need a lot of work. So, yeah, I don't know. I think for me, Soil Sisters seems like a breakthrough because it opened up a whole range of materials that were problems to become part of the solution, but also thinking about how we degrade things safely really changes what we work with, you know. How do we dilute the toxic stuff, and how do we make use of the things that may have shorter lives but still are non-toxic and easy to work with. I mean, we work with cassava glue in the textile fiber boards. That's already in the market. Everybody knows how to use it. So, yeah, I think that direction's probably where we're going to push forward the most. Yeah. Is there any, or do I have to, is there one last question? Okay.
Mae-ling, merci. Merci à tout le monde. On vous invite à continuer la discussion autour des rafraîchissements et les amuse-bouches, mais aussi on continue la quatrième semaine avec les fellows et nos facultés. On va faire le déplacement à Ouakam. On sera à Kenou, laboratoire des imaginaires, pour la semaine prochaine. Le programme public aura lieu le mercredi à 18h avec Kenou, laboratoire des imaginaires. Donc, on vous invite là-bas. Et merci. Bonne nuit. Merci, Mae-ling.